So now in this video, we want to make an adjustable linear voltage regulator. So you take a higher voltage in, you get a voltage out. The 7805 is really common, and it outputs 5 volts. That's what it's intended for. Usually the ground pin goes to ground, it monitors that voltage, and raises or lowers it as needed to hold 5 volts right there. So now instead of putting ground directly to ground, we're putting it between two resistive elements. This one though, the trim pot, we can set all the way to ground, a direct connection if we move the wiper, and then if we move the wiper farther away, there's more resistance between those 2 points. So if we put the wiper all the way up to where the ground pin is, that'll bring a direct connection to actual ground. We will have 5 volts out. So that'll be our starting point. As we add resistance though, you will see that we're making a farther and farther away connection from ground, and so it's going to take more voltage to raise the voltage there to hold 5 volts, and ultimately we'll have a higher voltage there in relationship to ground, and we can get to probably a couple volts below whatever the supply is. Now this does not make a even if we set the wiper here, it does not make a great voltage divider because the ground pin needs current coming into it, and these are relatively high value components compared to that, unfortunately. So that's the best we can do, just start here and keep adding up. There's really no voltage divider formula that will work because the current needed is throwing it off. So I just wanted to point that out right now. We have here from the positive supply to the negative supply one of the capacitors that helps stabilize things with the integrated circuit for the voltage coming in, 0.22 microfarad. That's what I saw on the data sheet that basically showed this same circuit, except for I added the values of resistance right there. Now I use the 10K because I have a really nice 10K trim pot, and so that's all I did testing with. But I found when it comes to this resistor, if you have, I tried a 1 kilo ohm resistor, so lower resistance, I just barely moved the trim pot and the voltage quickly shot up from 5 volts going up to almost the supply voltage. With 10 kilo ohm resistor there, I have to move the trim pot quite a bit farther, and so it's a lot easier to set the voltage. So maybe you even want to go higher, but 10K is a really common value, so I figured I would stick with that. Here is the pin layout here for the 7805. When you're looking at the plastic, there's a metal tab in the back. Left pin is the input, middle pin is the ground, as is the tab. That's directly connected, and then the pin to the right is the output. And here we are on the board. Probably looks a lot more simple than it did on schematic even. So we have the capacitor there. That's really smoothing the voltage to the input, the top pin up there, which a little hard to see, but we got the input pin on top. Right below it we have the ground pin right there. That's really what's monitoring the voltage difference between those two pins. And we got the trim pot there and the 10K fixed resistor right here. So that's going to the output, the bottom pin. Now we have the trim pot. Right now the wiper is set all the way, I can't turn it anymore, to where that jumper is. So there's practically no resistance between those 2 points to the wiper there. There's a resistive element here, and at the other end of the resistive element we have that jumper there, but which is also going to ground. But since there's no resistance here, the circuit's going to ignore the rest of the resistance. It only looks at where the wiper is attached. If for some reason the wiper fails, it doesn't make a connection anymore, then the circuit would just see the full resistance. Now this will be 5 volts here. I don't have to turn it all the way there to get the supply voltage. I actually don't have to turn it very far. We'll have the supply voltage anything farther, and it'll just stay as close to the supply voltage as it can get, almost 2 volts less. And so now we have the multimeter ready. The power supply set to 15 volts right there, and you can also look at the current too if you find that kind of interesting, but more important is the voltage. So we're going to set the meter to measure voltage, and I have the probes here. I have alligator clips that I clipped to the probes. They're crimped onto these jumpers so that I can take measurements wherever I want. So I want the voltage in relationship to ground, so I'll plug that one in right there. Now I can leave my hands free, and this one I want at the output right there of the 7805, and there you can see we got 5 volts right there. So according to the data sheet, this can have a minimum of 4.9 volts and a maximum of 5.1 volts when the ground pin is connected to ground. So we are within limits of the dash sheet. But here's the thing: when I turn the trim pot up now, the ground pin won't be connected directly to ground. The voltage will go up. So there you can see it quickly goes up, and once we get about halfway, we're just shy of that 15 volts of the supply right there. So there you go. If we had more supply voltage, it would keep going up. But let's go to 10 volts right now, and what we're going to do, so that's 10 volts at the output. I'm going to add a protective resistor. So this is 1 kilo ohm resistor, since we might get up to about 12 volts, and if we do something wrong, maybe even higher. And we're going to add an LED, and the LED should have lit up. I'm off a spot. I have to go here to where that resistor is. I'm going to share a slot. I should do the slot next to it. But any case, there you go. You can see that we got the LED lit, and the voltage stayed the same. So now we can lower it. The LED will get dimmer, and quickly raise it. We might as well go up to 12 volts if we can. So let's see how it does at 12 volts. That's getting a little close to the 15 supply voltage. But if you need more supply voltage, we can quickly increase that. 11.76. Let's just stop there so we don't drag this out forever. So I'm going to hit that. Now I got to go over to that spot. We can raise the voltage, 16.7, the supply voltage. So it's changing a little bit, but it's holding pretty true right there. So I think if we were at a lower voltage, it would hold better, because we were getting close to the supply voltage before. But there you go. Let's try 11.82 and work our way down. So you can see it's holding really steady at that point. Changing a little bit, but not too bad at all. So in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other ones I'm posting. Click like, subscribe, the bell, all that. Donate Patreon if you can. I got links down in the description. That helps out the most. But just watching as many videos as you can helps out a ton. Thanks to everybody that does that. I will see you in the next video.